Okay, well, we will start the session. It is 10:03 a.m. Mountain, so we will get things going. So good morning, everyone. Welcome to the CES Partner Session at ConvergX, or CES Partner Session ConvergX. My name is Kimberly Van Vliet, founder and CEO of Wave and ConvergX, and I have Brad Robson here with me, who will be our moderator today, and also happens to be the president and COO of Wave and ConvergX. We're here presenting the Congress ConvergX. ConvergX is the first and only annual 2.5-day global Congress that creates cross-sector investment and business development opportunities in the energy, military, tech, mining, ag, construction, aerospace, defense, and security industries. ConvergX, in its basic idea, is how do we stop reinventing the wheel? It is about shaking things up and being provocative. It is that ideas are powerful, but they're more powerful when they're multiplied across companies, across sectors, across industries. No consumer technology, at least none of the pervasive ones that are used today, started as consumer technologies. They started somewhere else. They started usually in the defense or industrial spaces. It took years, sometimes decades, for them to make it into consumer hands. And look at what we have done with that as a society and as an industry. You, the experts in consumer technology, have done incredible things with the industrial platforms. ConvergX brings together leaders from industry, decision makers, and thought leaders from all industries around the world to ask the questions. Where else can I take my company's technology, including into the consumer space? Where can I find solutions to my problem, as the tech doesn't exist in my own industry? Is there another company that has complementary technology that can enhance a project that I'm working on? Today, we have together a panel of amazing thought leaders from incredible companies to discuss the theme of robotics to accelerate Industry 4.0 across global sectors. Brad will introduce them shortly. We will then meet Dr. Geordie Rose from D-Wave and Sanctuary AI, whose talk is entitled Partnering to Deploy Initial Use Cases of Robotics with General Intelligence. Last but not least, we will be hearing from Eric Fournier, Director General Innovation for the Assistant Deputy Minister of Science and Technology in Canada, and Audrey Billingsley, Director of Consulting for Government Programs in the United States for Hardin Enterprises, Lord Rockwell LLC, and Rugby Schools Inc. They will just be discussing amazing programs that can be accessible to companies from around the world. During these sessions, we welcome questions and discussion. So please feel free to use the chat to enter your questions, and we'll do our best to make sure those questions are answered. So without further ado, I would like to now turn it over to Brad to kick things off. Brad, you have control.
Hi, thanks, Kim, and welcome everybody to this CES Partner Program. I'm sure some of you have taken in, or perhaps all of you have taken in, some of the amazing things that took place over the last couple of days, where we had presentations from everyone from what is happening at the International Space Station right through to what the next best and greatest gaming chair will be. So there's nothing like having a wide variety of topics and entertainment and education from the CES show. So thank you very much for joining us today. It's been a unique waiting game in order for this panel to get started. ConvergX is also privileged and proud to be a partner of the CES virtual event that took place over the last couple of days. And to get our panel started, it will be a discussion around robotics and how to accelerate the 4.0 across many different sectors. What I'd like to do is allow the panelists to introduce themselves. And I'll start with Dr. Donna Duolo. So Donna, if you could introduce yourself and your background as well, please. Thanks, Donna.
Thank you, Brad. My name is Donna Duolo. I've been with the Department of Defense for 33 years. I've also been in academia for approximately 20 years. My specialty is aviation and aviation robotics and aviation computer science and mathematics. I also have a law degree, and I write law books for the American Bar Association on drone law. So my focus really is around aviation software safety, and aviation software security. And I feel very fortunate to be here today. Thanks, Brad.
Oh, thank you, Donna. We really appreciate you taking the time out today as well, too. To the next on the list is Sylvain. Sylvain, would you introduce yourself, please?
Thank you, Brad. Thank you for the invite and be part of such an elite group. And I am sure a very interesting and educational session. I come from a purely military background, 28 years, retired as a brigadier general after 7 operational missions or deployments, right up to 16 months in Afghanistan and other peace and war scenarios, commanded troops in the NORAD system with the United Nations. And I had the privilege of working with the Governor General and the Minister of National Defense as an advisor, bringing quite a bit of an outlook for a military officer onto politics and larger piece of defense and industry. Since I retired, I've worked at a National Energy Board, bringing another element of education, managing pipeline and how we sell and receive oil and gas in Canada and how we monitor it. And lately joined BRP as the head of global sales for government across, well, again, global stage, but international sales and building their sales portfolio and increasing sales there. Thank you so much.
Thank you. Hey, thanks, Sylvain. Really appreciate your time today as well, too. Leah?
Yeah, hey, can y'all hear me?
Perfect.
Okay, yeah. Yeah, hi, I'm Leah Lasala. I'm the CEO of Pan American Drone, formerly Astral AR. I've been working with drones ever, we founded, 6 years ago? And developing our technology, drone technology, sensor fusion, machine learning, AI, all enabled with flight capabilities and autonomous navigation. We build drones that stop bullets, and I have the advantage of having worked with Dr. Dulo and also with Christy in the past, and that's been super cool and fantastic. And I want to be just like Donna when I grow up. That's the truth.
Yeah, she was pretty cool. Thanks, Leah. Janine, to you next.
Oh, thank you very much. So Janine Adams, I'm the CEO and founder of Centurion Cyber Defense, as well as Retrain Canada. Centurion, we are a Canadian company. We're staffed with a lot of former police officers and military people. We actually, my president is Sat Parhar, the former Deputy Chief of Police, Calgary Police Services. We have a number of white hat hackers, and you know, we've got locations: Calgary, Edmonton, Ottawa, and actually a location in Tennessee and Georgia as well. We focus on cyber training, cyber security services, security product development, as well as ransomware negotiations. Actually, Sat Parhar has got an extensive experience in that field. We've got over 30 staff, and yeah, my background is so telecom, banking, oil and gas, fraud detection in banking, and got a degree in neuropsychology. So kind of what we are.
Thanks, Janine. And Christy, finally, if you can introduce yourself and your background, please. Thanks.
Of course. Pleasure to meet everyone. Christy Lee Minahan. I have a bit of a different background from the other panelists. I've been working in the blockchain and fintech space for 10 plus years now. Currently Chief Product Officer of Ernst Lights Labs, a computational imaging company focused on improving image quality for all sorts of devices. And I have spent the last five to 6 years working on building out data centers and all sorts of infrastructure around artificial intelligence and fintech solutions.
And the one thing that you left out is self-taught, which is even more amazing as well too. So you're a natural. And I bring that up because prior to this, obviously we had a panel group call, And it's going to be very difficult for me to lead or to help guide and direct and moderate this particular panel, because I want to listen again to everything that we went through regarding robotics and how we're going to advance the social acceptance as well as innovation and disruptive innovation in this particular space. So as we jump right into it, the definition that we sort of created as a group, as a bit of a working title, is how we're going to enhance the adoption of innovation and enhance it with smart and autonomous systems fueled by data and machine learning. As you can certainly hear by all our panelists' background, they are deep, skilled, and well passionate about this particular topic. And what we thought might be a great way to start is to have a definition around robotics and what Industry 4.0 is. So Donna, if I could turn to you to describe to us what your definition and what we are understanding the definition of robotics and what autonomous and that kind of scenario is. And if you could lead us off, here we go with our panel. Thank you again.
Yeah, thanks, Brad. Anytime you talk about robotics, you really need to start with the classical definition of a robot. And a robot is basically a system that takes sensory input, decides its internal state and the state of its current environment, and then acts upon those calculations and decisions in an autonomous manner. Now that's the classical definition. Now we have systems that have come on board where we have what we call an autonomy spectrum, where the system can actually have full human control all the way ranging to full autonomous control. And in many systems, that autonomy can be any part of that spectrum. So really with the more modern definition of robot, a robot is going to be the same thing with sensory input, but it's going to have capabilities for humans to intervene. And in many cases, this intervention is for safety reasons. It may be for security reasons, or a human thought process in one step of the decision chain may be absolutely necessary. Now, what is not a robot is a system that is pre-programmed and makes no decisions on its own based off of any sensory input. So when we're talking about robotics, we need sensory input, we need the system to be making its own decisions, and we need the system to actually act intelligently and correctly on that input to make its decisions that fulfill the requirements and mission of that particular system.
Thanks, Donna. One of the things that you mentioned that tweaks my attention is when something is pre-programmed, we don't treat that as robotics. But I would challenge that Leah perhaps has a different point of view, that when you put artificial intelligence and a prescriptive path or plan or protocol within something that's a robot, for example, wouldn't that be considered robotics, or is that under more of an autonomous?
So just to make sure that I understand your question or the context that we're approaching this, what you have is you've included some degree of, you use the term AI. I'm just going to say that we're just going to blanket that and include machine learning, but you have sensory data, you have a prescribed set of behaviors that are desired, but they are not, what Donna means when she says, what Donna is describing as being not a robot, think more like mechanical or mechanically assisted assembly line, where you have, for example, machinery that lifts parts of cars and puts them into place for the purpose of assembling, like for example, a vehicle. As sophisticated as it appears, it's not making anything that could be considered a decision, even so much as, if else decision making is not within its capabilities. It's performing precisely the same action over and over again. That is not a robot. A robot is making some degree of decision at some point. And I believe like the example that I think I launched into originally was starting from the question of what do you want it to do? And using that to be the guide to scope those capabilities. If you don't need it to make decisions, you don't need a robot. But if you do need it to make some sort of discernment based on, and that's something Donna mentioned specifically, its environment, assessing or somehow interpreting the context of its environment and responding to that as well.
Oh, thanks,
That make
Lee.
sense?
Yeah, it sure does. And I think that ties into what Christy does quite well is, and the second part of our definition is, what is the Industrial 4.0 revolution? What are we doing with this technology and this capability? And Christy, I think you've got a couple of really good examples and some insight, and then we'll, that you can share with us as well, as about what you've done with the sensors, with the data, with the information, and what the machine learning Industrial 4.0 is. So Christy, I'll turn it to you.
Yeah, I guess the best example I can use is the work that I did with Leah in a previous life. So we were able to make Leah's robots be quite sufficient in terms of being able to mine cryptocurrency. And now I know what that sounds like, but essentially it allows for the drones themselves to pay for part of their OpEx costs, so the storage of their data, and the electricity that they consume while they're charging. And that transformation piece and how we think about the hardware that we deploy and how it works during its downtime is quite interesting. So through the process, we were able to ensure that these drones, while they were docked and while they were mining, were able to pay for part of their OpEx costs, which made the upfront capital investment for them much more appealing. And more importantly, it helped subsidize some of the costs. So as these were being deployed in low-cost regions, in education, etc., it helped make them a viable form of technology. Otherwise, when you're deploying any kind of robotics, you have to start thinking about, okay, well, I have the upfront CapEx cost, the cost of actually buying the device. Then there's ongoing maintenance costs. It does need to be connected. You do need to be storing this data somewhere that you are collecting, backing that up. So that has to be paid for. Internet connectivity has to be paid for in some way. So there are these recurring ongoing costs. If all of a sudden you can build out pathways or build out, and the ability to pay for part of that, it becomes much more appealing. And I think as we come into the Industry 4.0 world that we're slowly building, a lot of this is, machines that are very self-sufficient and capable of operating on their own. They're able to make decisions on their own. And most importantly, we're able to see the rationale around those decisions. We're able to see what they were doing versus what has historically happened, where they sometimes have operated in a bit of a black box. Maybe not to the engineers that build them, but definitely to the people that deploy them and the organizations that use them.
Thank you, Christy. Sylvain, I'll turn to you. A lot of what Christy was talking about, you have a experience in both scenarios or both industries, being defense and also with BRP. When you take some of the points of view that you've had with serving with the RCAF, we understand that there's some autonomous, there's some robotics, there's some artificial intelligence and sensors there, but also the work that you see from a commercialized and industrial operation of using drone or autonomous and artificial intelligence from your background, more from the delivery of business and OpEx recap, and making money. That's what we're all want to talk about as well too, is how can you make money at this and what is it that we should be looking at? Sylvain?
Yeah, thanks, Rob. The spectrum of, the autonomy spectrum that Donna was talking about for me is that fascinating part of human involvement at different stage. There's parts of flying an airplane that are automatic. You push a button and things happen on their own. They cannot be left alone, however, and that human intervention at different stages is important. So I use this one because I'm most familiar with. However, it applies to land operation, automatic missile systems. When certain parameters are met, then there's a function that releases weaponry of some site of defensive mechanism on its own. This is where sometimes, it is important to go back to that definition. I appreciate you started there, because as this automatic or the more automatic portion And as you raise through or you grow through the spectrum of autonomy, then in my defense experience, then you get into immense challenges of robots conducting war and the social acceptation and the respect of things like the Geneva Convention. Now, I won't go too long on this subject because we could spend hours and hours deliberating on it, but major evolution like Industry 4.0 allow these major leaps like the bow and arrow in warfare, the tank, and things that create this more rapid. And I think this is now this phase of evolution is more about, some of you may have heard of the OODA loop. So it's the concept of going faster than the enemy in your growth. And so the industry to me is a key enabler there. And I look forward to Mr. Fournier's presentation because that's what he deals every day with. And that's what we're challenged with. On the BRP side and the pure manufacturing, which is more, in direct line of what we're talking about, I have found it very impressive looking at it from the outside, watching the production systems evolve. And for me, the most important piece that I saw is the way that people learn, and where machine learning has improved this capacity. And at BRP, there is a very stringent gate process that goes from evaluation of the market in 5 years to launching a product, to maintaining it and providing parts for the following years. Those are the major steps. In there is the production portion where there are some major savings for the company to always be on top of new technology and making sure the loss rate is reduced, accidents, so there's a safety aspect. So I'm not answering a whole lot here, but what I'm telling you is that there's so much there that is required for collaboration at both ends of manufacturing and actual user. That also, and I think these kinds of conferences allow for a tighter circle, and not for companies who are maybe represented today to access defense experts, and they don't know how to get there because it's very cumbersome.
Thank you, Sylvain. What I hear is we have technology, we have products that are developed that can operate on their own or with some instruction, and then we have data and artificial intelligence and risk. So before I get to a question for Janine, I wouldn't mind if we could, if this could be for anybody on the panel to take this question or provide this explanation. So we have artificial intelligence, we have the need to remove humans from dull, dirty, and dangerous positions, and we need to improve our continued quality of life. Is there a way that we can define how much risk or capability we want to give to robots or robotics or autonomous objects, as well as how much control do we really need to keep a hold of? I'll offer that to anyone on the panel.
I'll do it if you guys, this is something that we had to directly address when we were developing our technology. We worked, so when we were developing our technology, we worked directly with uniformed law enforcement, shoulder to shoulder, where they told us what they wanted it to do, and we made it do that. And then we put armor on it because, under promise, over deliver. Yeah, sure, why not? So when we realized what we had, we developed, the capability to identify specific objects within solid objects beyond visual line of sight and react to those objects predictively, if you will. The ability to do something in advance, we had to decide very quickly and very definitively what do something is going to mean. Specifically, when we say that these drones stop bullets, what does that mean? We put armor on them for a reason. The ability to identify these objects in advance of them being brought into play, the situational awareness, the value of the situational awareness alone, we could have skipped the armor. because that alone was enough. But the ability to potentially intervene, what is that intervention going to look like, and where does it need to end? And what we determined was that the machine cannot be that smart. It can be smart enough to help. It needs to be a tool, not a partner. And as sophisticated as it may appear, and this is something that we had, I mean, we constantly, we always have to remind the law enforcement that we work with, is that it cannot make human level decisions. You don't want it to do that. You need to make decisions like, for example, when to deploy a taser or when to use pepper spray. The machine needs to not decide that, if that makes sense.
It does. Thanks.
Yeah.
You would also want to assess where the system's actually operating. Is it the strategic, the tactical, or the operational level? And then once you determine what level it's going to be at, then you determine your threats, your vulnerabilities to give you your risk. Now, the amount of money, the amount of effort would be applied to give you your residual risk. Now, your residual risk would be a determinant of your organization. How much residual risk would you be willing to take on with that system? So assessing risk is a very complicated situation. So you need to take in all factors from all different levels of operation to really come up with some type of answer to that question.
Yeah, exactly. And I hear the word tool, or utilizing that technology and that capability as a tool set. Janine, so when coming to you specifically, obviously from cyber and security, there's no better way to reduce risk than ensuring that whatever we're sending out as an object or an asset or a tool in either defense or community service or even machine learning, how do we mitigate more of that risk by securing it, ensuring that we are comfortable in the fact that it's operating in a particular way and it won't be misused? Janine, I'll turn that to you.
Thank you very much. So, it's interesting, right? When I think about what we're talking about today, we're talking about creating some convenience for people and for organizations, some cost savings, and then we've got the interaction with public potentially in terms of how robots are used in it. And then we've got this change of skill sets. And, in terms of pulling all of that stuff together, it's always a balance of all of those different things. Anytime you make something convenient, you make it easy to hack. And there's just no way around that. And so, when we look at things like, how do we make it safer? Well, we're going to have to really start to look at how we're operating and what our expectations are. I mean, companies these days, they still don't understand, for the most part, their current risk of cybersecurity. So now we're adding a dynamic of something that potentially could be serving clients. So you've got that public interaction. Well, there's huge concerns on that, and I know that a lot of research, Boston University, for example, has been just showing how easy it is to hack robots. So, and we've also got, in terms of the dark web, for example, we already have industries who are looking for robot operating systems so that they can find that information and then start to take control. So, what I see we need to do is, as companies, we've got to understand more what these real risks are, and then we've got to be prepared. I know that one of the other panelists talked about cost savings. Well, you might save in one area, but you've got to be prepared to spend in another area. Otherwise, you're just opening up a whole bunch of risk. And I guess the assumption is that, as much as we're innovating these wonderful products, I can assure you that on the dark web, the hackers are innovating just as hard.
No doubt.
How do they say that? They say the bad guys have smart people too.
Yes, exactly.
Yes, sure.
Exactly.
I'd also like to remind those individuals that are participating with us today, and thank you very much for joining us, is please post any questions that you may have in the chat or the Q&A. Be more than happy to address those throughout the presentation as well. So just wanted to remind you of that functionality. Donna, I want to hop back to you for a brief moment. When we had our panel review conversation, you were talking about the automation spectrum, or my word for it was the automation, or perhaps it was yours and I'm just borrowing it. Thank you. The automation spectrum. And I think if we had a conversation, if we started a next avenue of discussion is, what does that spectrum look like and what we want to automate and where some of that risk and innovation and disruption can be. And I think that might be a neat avenue for us to continue on our conversation.
Well, we would want to automate the things that basically we want done more efficiently or more effectively, or as you said, the dirty, dull, and dangerous tasks that the autonomous system would perform. We would need to actually do a safety assessment and also a security assessment to see what type of risk is going to be inherent in those autonomous tasks. Then once we do that, we could then strategically place our system on the autonomy spectrum, where we would have a balance of safety, security, and functionality. So it really, there's no key definition. It would have to go back to the requirements of the system. The requirements of the system, the safety requirements, and the security requirements. But it's very important to plan this out before we start implementing the system, because once we start implementing the system, it may be hard to change these specific requirements, and we don't want to wait till the system is operational to find out that it has a safety issue, a security flaw, vulnerabilities that can be exploited by threats. So it's really a strategic planning operation in the requirements phase. And a lot of organizations kind of go through the requirements phase of system development rather rapidly. And unfortunately, that can yield unpleasant dividends in the end. So my recommendation for any system is spend your time in the requirements so that when your system goes online, you already know where the autonomous spectrum is going to be and where human intervention may be necessary.
Sylvain, I'm sure you've got a point of view or two on exactly that, process planning systems of systems in both the careers you've had. Would you have something like that?
Definitely. I listened to Janine on the use by the not so good people to stop whatever we want to accomplish, whether it be on the cyber side, on the physical side. And Donna, that brings in this component of planning, and military folks who are on the line, and those who are not, have not lived close to military, we plan and replan. And the old adage with the military is no plan survives contact with the enemy. So to me, we still do planning, right? And we have plans for different operations that will stay on the shelves. To me, when I reflect on what Janine and Don are talking about, is really about predictive behavior. Predictive behavior from the robot to bring it to the level of all the things that all the panelists have talked about, bring it so close to that level of participation, contribution, to the point that we understand the predictive nature of its behavior. Because if we understand that, then we can also then almost sort of piggyback of that component of behavior, and then understand how the enemy or the folks who are not in collaboration with us will react. Predictive behavior on a assembly line at BRP is the same thing, right? As we put the collaboration of human intervention and robots together, that needs to, the human creativity, right? I hope will always outweigh that of the robot. And if that is the case for a specific outcome, then to me, we have to focus on that predictive behavior so that we always understand how far that robot's going to go, so we intervene or not. Autopilot is, I'll leave it at that, it's just that, but cannot be left alone. So I am a bit scared of auto vehicles, for example, that we seem to be aiming at, but maybe I'm just old.
Or just a person that loves to be in control of whatever you're driving or being part of.
More, yeah, that's right.
Christy, I want to go to you. Sylvain mentioned a couple of things that sort of stand out in my mind. There's innovation, there's invention, and then there's what does the human requirement or the human expectation of that technology intersection look like? And you've got a couple of examples. I'm going specific to home automation and home control, and I think that's an excellent example for you to bring forward, as well as help lead us in the understanding of where we should innovate and how we can, what the intersection of this technology bridge now is affording us, and how we can improve our lives, so to speak.
A big part of where innovation needs to sit right now is in optimization. What I specifically mean by that is making sure that every single unit of energy that you're spending is being sufficiently used. And this includes, a device's idle time. So any device, it doesn't sleep like we do. It doesn't require any sort of downtime, any sort of wait period. You can plug it into the wall to charge, but it's still always on, always connected, always running. And so during that downtime period where you as a human aren't engaging with the device, you want to ensure that it's doing things in its spare time, its spare capacity. This could be using, the cycles of the device for quick ML ops. This could be using the cycles of the device to make money through selling out compute power. There's all sorts of different applications with that. And I know the example that you want me to bring up, Brad, which is for the audience. My current residence has all of the Google Nest thermostats mining cryptocurrency, as well as my TVs and any of the smart devices that I've been able to modify the firmware on. So essentially that means that I can bring in roughly, $30 to $40 per month, sometimes up to 150 or more, just through these devices constantly contributing to cryptocurrency networks. There's automation in place where, the coins are immediately converted into USD as well. So you're not actually dabbling in that risk. And that opportunity is only afforded to me because of how someone out there is willing to pay for those cycles, essentially. And there is a future in the world where all of your smart devices could be instead doing something a little bit more useful. So instead of just, mining cryptocurrency, they could be contributing to some very low-based edge computing. And I think as we make more advancements in the hardware space, that is a real possibility. As silly as it is, with the advancements we're making in edge computing, you could have, a smart toaster or a smart coffee machine actually contributing to some real scientific research.
Fascinating. And you're right. Thank you. I was dropping some very subtle hints, and that's exactly what I wanted you to bring forward. So thank you for that. But it leads me to I want to put this to the panel. I'm not sure who would like to take this first or this question on to lead us down this path, but I know a lot of brilliant people. Most are always thinking of ways of inventing something to take effect of advancements in technology, whether it's blockchain, data science, creating something in nano, totally automate something, sensors, systems on systems, a variety of terms and phrases and concepts that we know. I wonder, is our expectation as a society is to have technology just get us to a particular point and we say, aha, I like that, let's start using that? Or should we pursue it another way, understand what we as humans and society and businesses are prepared for? Is there a right way to approach how to combine what we're talking about today? And should it be inventive? Should it be innovative? Or should it just be, we expect it because we saw it on TV at some point?
Well, if you're looking at invention versus innovation, an invention is something that does a task. An innovation is something is basically taking that object and making it affect society as a whole. Basically, it's going to be disruptive. It's going to change the way we do things. So to say that an invention, we need a methodology for an invention to go into society, I think that the market and society and the environment is going to determine that. A society is going to determine whether we need this or whether we don't need this, whether we're going to pay money for this or not. So to have a specific algorithm or specific way an invention becomes an innovation, it's very difficult. There's literally, hundreds of thousands of people who have created inventions, but only very few that have actually brought it to the innovation stage that really has changed society. So it really depends on the needs of society, the needs of the current environment, and the willingness of society and business to adopt these inventions as well. And also you need a champion. You're not going to have an invention become an innovation unless you have somebody that actually puts it out there, that markets it, that champions it. And that's where you see throughout history, you have champions like Bill Gates and Steve Jobs. They're not just inventors, they're innovators, because they got the things that they thought would work out into society to actually make a difference in society. So it really depends a lot on society, who's championing and how good the invention actually is to determine whether it's going to be an innovation or not.
Anyone else on the panel want to comment?
I may share an actual experience of this kind where folks, when I retired, contacted me because of some of the work I've done in international operations, and companies were approaching them to sell their products. Innovation. Ski goggles is one example. Certainly not invented over the last 2 years. Certainly not. They've been around for a while. However, this fine gentleman started very much the road to non-foggy goggles for skiers out there, for snowmobilers out there, any type of other sports. Goggles and glass have a tendency to fog. And so Special Forces Command asked me to, at the US SOCOM in Florida, asked me to sort of test what this was about. This was one of several thousand offers they've had. And this fine gentleman and I had a conversation, and basically I said, send me a set of goggles. He got it to market. He sold hundreds and hundreds of these goggles. And I don't plan to have any unpaid advertising here, but it was there was a need out there. It was evolutionary, met the goals of there's a demand there. Now, and another one of those that I'm still sort of working on is return shooting glass. There's a need out there for a piece of glass that can stop ballistic fire on you while you still remain protected and shoot back. Obviously, who would not want to be still protected behind some type of wall, this one where you can actually see? But this technology is just not getting there. Again, I fully align with Donna, stakeholder, champion, readiness of the technology, readiness of the society to accept it, and so forth and so forth. So very interesting dynamic as to what are those components of success that get these innovations, these are not inventions. Somebody invented glass before, right? Just like goggles, the same thing. But we still are unable to get that technology to market to protect the men and women who defend us every day, including, bank tellers, right? For those who still go to the bank.
Or schools or educational facilities. Thanks.
Absolutely.
Thanks, I have this thought in my mind that, and Donna, thank you for bringing that home, where invention is a task, a tool, something that you just either think of and happen upon, but innovation, again, that separation. Janine, I want to pose the question to you that technology is advancing so rapidly, and we may not be adopting it as quickly or understanding it as quickly as we need to. And I would look to you, Janine, to see, I know there's equally smart people that are doing bad things and equally smart people that are doing great things. What does that intersection point look like to you? And what should we as innovators, or what should we as developing at that crossroads of technology and software and data analytics and using that technology as a tool, what should we be considering, and what does the future hold in that cybersecurity, that not able to hack Christie's fridge as it's generating a tremendous amount of money for her and zero net operations?
So, you know, it's a great question, and I think it really boils down to a lot of education, you know, understanding the technology and, you know, really taking a hard look at it in terms of, you know, what sort of areas would this technology impact? And, you know, when people are talking, I'm thinking about, you know, what roles would need to understand cybersecurity, because there's a lot that they don't right now. They don't have to worry about it, or they're looking at it in terms of, you know, they've done an algorithm and so they're fine. And I'm talking specifically about insurance, for example, where, you know, they know that their algorithms, I mean, they were based on sort of a set of expectations, which, you know, in terms of where we are right now has completely changed. And so now, you know, they're having to change how they look at what they pay out and what the requirements are in terms of allowing a company to have insurance. So that, you know, there's that. Then when we look at things like hospitals, for example, you know, there's a lot of research that's showing, you know, just how vulnerable these robots are. And when you look at things like ransomware, well, what if you had like surgery ransomware? So somebody's doing remote surgery, and now all of a sudden, you know, somebody hacks in, and, you know, for whatever $200,000, we promise not to stab whoever, you know what I mean? Like these are things that happen. There's also, as well, in terms of when you're looking at manufacturing, for example, this idea of micro defects. So putting in, you know, a very small defect that doesn't actually get detected until, you know, a drone is flying and then it crashes or whatever. Like these are the kinds of things that we've got to look at. Quality control, you know, our operations processes. Now, all of these things we need to actually understand what the impacts are from a cybersecurity perspective. And they all, these changes of skill sets, it's one of the things that, you know, for us, we're really dedicated to, is making sure that people understand what they're actually getting into, and looking at that bigger picture, because you know, the risk is it changes, and it's growing. So.
Well, thanks, Janine. What I hear, and then there was a question asked by one of the participants as well around transparency around those security risks. And I think on the one hand, we hear from innovation or invention that something will be delivered, and yet we don't understand what the risk of not controlling it, not securing it, not treating it as a tool. And we also need to understand what we should do in order to secure it and utilize it, like in smart cities, like engaging in a traffic grid. Thank you for bringing up something else I've never thought of, which is ransomware in a surgical hospital as you're performing open heart surgery. Quite novel an idea. So I think let's start talking with the amount of time we have left for the panel. Let's start talking about where should we start taking this at this crossroads of intersection of technology, data science, artificial intelligence, training, machine learning, et cetera. What industries or what solutions should we start or promoting or focus on as what we should be doing in the future? And that's kind of a long roundabout question that meant nothing to me either, so I'll restate it. Let's take a look at where we see the future of developing technology to advance the machine learning revolution and improving society, such as smart cities, such as microtechnology, cybersecurity, those sorts of things. Leah, let's start with you, since you're kind of brushing up against delivering some innovative technology that is in that space.
So basically, what your question is what I'm being asked. What do you want me to solve with drones?
Well,
I mean,
yeah.
Okay. So, I mean, we're solving gun violence. That's what we're solving. That's us. And the things that you can solve with these tools are, these tools can be used to solve agriculture. They can be used to solve logistics, inventory management, shipping, economies of scale have the potential to benefit enormously from even just a nominal amount of autonomous or semi-autonomous machine learning enhanced, if you will. We don't want to go all the way to AI. We're not teaching it to think. We just want it to identify, the difference between the Cheerios and the paper towels in your inventory in the warehouse, so that you can better organize those objects. The ability to sort and to apply the energy of society, of all of society, more effectively by using those tools. In our case specifically, we're solving a particular wicked problem that is driven by a degree of human unpredictability. The things that keep me up, at night as far as security is concerned, Donna, adversarial neural network, and the possibility of misidentifying or mistraining the model, and having it react poorly. And those are just, some of the things that you have to think about when you're trying to deploy, these technological solutions to such. That's one of the reasons why the first thing I always approach this with is, what are you trying to solve?
Thank you, Leah. Christy, I think I want to pose to you, to shape a question to you is, using technology and processes and having it automated, that theoretically can extend the life of a company, can extend the life of process and methodology and services as well. I think that's another avenue that we need to take a look at from a technology or a societal point. Would you agree?
I do. I think there are what I would call low value tasks that can simply be automated to speed up processes. So already you've seen a lot of advancement in technology doing things. We have, ServiceNow that sort of automated the business industry. You have DocuSign that kind of automated very small things, document processing in the legal field. And I think a step further needs to be taken on this. Very, very small automation. I see one of our viewers chatted about, or mentioned he looks forward to the day when, your self-driving vehicle can pick up your kids at a very specific time and then pick up a grocery order at a very specific time. Small automation like this can definitely happen. However, with the caveat that in order to get some of these things working, the entire stack has to be automated. What I mean by that is you can't just have one self-driving car on the road. You would need to have, the entire city be self-driving cars. If you have, humans as well as completely automated cars, that is where you introduce lots of room for error and you introduce issues. It's one of the biggest barriers to self-driving cars right now. It's that we can't quite figure out how we can make machines account for human error. So, you've got some barriers to that. I think there's just jumping back a little bit to the statement you made about where can we innovate in technology. I think right now in 2020, we saw that there needs to be much more innovation in media and how it's shared, and in verifying what media is correct and what media is not, specifically around imaging. We need better ways of proving whether or not an image is true from its source and point of creation. And if you think about it, right now we don't have any verification process. When you upload something to Twitter or Facebook, there is no verification process that says, this image was taken with this device and has not been altered in any way. And there needs to be, it's not even barriers, there just needs to be traceability on how an image was altered and how it was modified. And the important thing is that traceability, that history or chain of events, needs to also be combined or attached with the image. Otherwise, it's not going to do anyone any good. And so I think that is where the intersection of all of our expertise and skill set can kind of come into play. Jumping back forward to, better automation. I live for the day where, houses are entirely 100% automated, where, my my smart devices can sort of pay for themselves over a period of 9 months. And then the rest of the proceeds they make, the profit can go towards paying my energy bills. I live for the day where, my washing machine can sort of adjust itself to based upon it sensing how dirty the clothes are. And my microwave can kind of quickly figure out exactly how long it needs to run to cook the food. And interestingly, we're not too far away from doing some of those things. But then comes the cost of trying to scale, trying to make this accessible to all consumers for it to actually take off. And with that, you need better cost optimization, and you need a lot of scalability to get the cost of these new technologies down.
Fascinating. I like all those suggestions. Anybody who's listening, make all that happen. That would certainly help me out. Donna, I'd like to pose a question to you where you get to wear both your hats. So Christy brought up risk and responsibility. What is your opinion on who is going to be responsible, or who should be responsible for this automated world we're living in?
No, that's a very good question, Brad, because we need to actually look at the law. And when you look at the law and you look at technology, law always lags behind technology, at least 10, 15 years, sometimes 20 years. If you look throughout history, we had aircraft in the early 1900s. The FAA wasn't even founded until the 1950s. So it's a really delicate operation to try to figure out who's responsible when you don't have a legal foundation. So it's really up to our state, local, and federal leaders to be able to make regulations for technology, and also for industry to have ethics around their use of technology. So who would be responsible? That could be, somebody directly responsible, a second party, a third party, even somebody that's only remotely tangibly responsible. It would depend on the situation. It would depend on the current laws, and it would depend on really the situation that actually happened. Is it the manufacturer? Do we have a micro defect where we have an actual manufacturing issue? Or is it an operator issue? Or is a third party coming in and disrupting your system without warning? So the answer that it would depend. But as technologists, we really need to look at all of our liability, the totality of the circumstances, and protect ourselves from any possibility, whether it's a third-party hacker coming in, whether it's an internal threat, because 70% of our cyber threats are internal threats, people on the inside of the organization. So we really have to do very careful legal analysis, and we have to look inside ourselves as innovators, inventors, and companies. What are our ethics, and what is our responsibility to try to prevent things, even if it's from a third-party hacker or a second party or an insider. So that's a very, very critical point to look at, and we can't neglect that. We also need to look at that throughout the development of our product, not just as at the end state. We need to see who's responsible. Legal, ethical responsibility and requirements all need to happen throughout the life cycle and development cycle of our systems.
Thank you, Donna. All great points. Janine, I'd look to you then to say, well, Donna brought up internal hacking, external access. How are we going to secure that tool? And I now need to shift my mind to saying that what we're using from an automation or robotics as a tool to enhance or support. What is your industry doing, and what should those that are looking at cybersecurity, securing of assets, those sorts of things? Let's use an example in my mind of you're doing an organ donor transport. So a drone is used to take an organ from point A to point B, and then it's into the system. How do we ensure that it's very complicated and very important, but how do we ensure that piece, as an example, is secure from end to end and the mission is accomplished?
So there's a couple things. So we brought this up, Donna brought this up a little bit in that, a lot of the threats are internal. One of the things that we recognize is that, the only reason why things aren't any worse is because there's more good people than bad. So it's a reality that, we have to be aware that when we're working with people, there's an opportunity. People will take that opportunity sometimes, and I think being able to have processes in your company that support the recognition of issues is incredibly important. Making sure that you've got the right training in place so that if somebody runs into something, that they're able to deal with that. I think too that when we look at it, how you lock things down, you have to balance. Again, we talked about convenience and the ability to have a product safe. When we've got a wonderful robot that's dancing and doing wonderful things, it's using Wi-Fi. Wi-Fi is a very easy product to hack. So we've got to look at those kinds of things. I mean, most people they're focused more on what the robot's doing than the other stuff that's happening around. So we've got to really be more aware of what's going on around us as well. I think the other thing too is that when we look at who we're up against in terms of cybersecurity, I mean, there are, when you were looking at state-sponsored third-party hackers, I mean, these are people that have pretty much as much money as that they need and the resources, all that they need, and they're just sitting watching and waiting and then practicing. So we've got to look at things differently, and we've got to look at our businesses differently. When we look at where the risks are, we tend to look at sort of the big things when a real hacker is going in and they're misdirecting where people are looking, and then they're going in and they're going in through places that no one would expect. And this is where we have to look at things differently. We've got to actually do hacker testing. And while AI is wonderful, there's lots of things about AI that it will not detect. Humans, the creativity of humans that we've talked about is incredible, and they will find ways. And as I said, that from a dark web perspective, they're already working on stuff. I mean, they've got kiosks where you can go. You don't have to be a full-fledged hacker in that end-to-end how to hack. You just have to know whatever your specialty is, and then you go out and you buy the rest. It's just like in the regular world. You go, I this is my skill set, and I'll go buy the other skill set. So you can actually go buy software that will help hack people's banks and all those kinds of things. You don't have to be good at that. You just buy it. So being aware of that is, I think, a really good first step of getting educated.
Thank you, Janine. Last question, and then we'll take a look at the questions and see if there's any other input from those that are participating. Sylvain, I'm going to go with you. So Janine brings great comments up about utilization, well, let me just change it again. So when we automate things, we are potentially taking a role away from a human being, and we're now putting a machine or a tool in place. Then we also need to ensure that that function is going to be safe and secure. You've seen that in the military, where automation removes people from a dangerous particular situation, but you're also experiencing that in the commercial industrial side of your business, where you're putting an automated tool in play. Are we really replacing people, or are we just elevating what society and humans should be doing anyways, which is controlling a tool and having that machine take the risk of being broken or shot or just automated? It's kind of a, I'll just leave it there. I'll let you go, Sophie.
Yeah, this is quite a challenge. I mean, societal evolution is not an area of knowledge of mine, right? I sort of live it and then try and contribute in the segments that I have in the past. But replacement of human beings brings, in one of the comments in the chat room, it brings out very clearly, there is an ethical challenge to what we're really trying to do and how we're doing it. And some of the, I think, from my very personal, humble perspective, the companies that actually are more successful, if I was a CEO of one of them companies, I would certainly try and embrace technology, try and replace the human being, but in the process also make sure that you have the transition of learning, and then you take the folks into different areas. It sounds very easy to do. It's a very challenging premise, because over time there are jobs that will go away, and you know, they are being replaced by folks that will have to defend against cyber attacks. They did not exist when I went to high school. They just didn't exist. Cell phone companies, they just didn't exist. But there are obviously, and regrettably, I think society, you know, has a degree of anticipated loss through this. Some of the folks will not, either by choice, by abilities, will not retrain into new technologies as society advances. Very humble opinion. I would love a challenge to this, just if anything, to educate myself on other views out there.
Great, thank you, Sylvain. So what I'm going to do now is take a look at some of the questions that have been posed in the chat. There's a couple of individuals that want to ask a question directly. I'll get to you in just one moment. Some of the questions have been revolving around, I guess, the ethics. Best way to describe it would be the ethics, or are we okay with a robot or autonomous process that causes harm to an individual? And again, Don, I think you addressed that earlier, where we need to understand what the legal systems are and what processes are in place there and what we're willing to accept. Don, I'll leave the overview for you there.
Well, when we look at systems, we would have to see basically what kind of damage it can do and what ethical and legal parameters. Like with war, we would have to follow the Geneva Convention, and anything that would deviate from that would be unacceptable. But then would we want to actually put the life or death of a person in the hands of an autonomous system? What if it's the wrong person? What if it's the wrong crime we're charging them with? What if they're actually, you know, a friendly instead of a belligerent? So it's a very, very complicated system, and I don't believe we're going to solve it anytime soon, because it's going to require really, really advanced artificial intelligence. It's not just a simple thing that you can program a robot to do. So we really need to look at the ethical spectrum, we need to look at our legal spectrum, and we need to look at our autonomous spectrum and see how they would align. And then unless they align when we're about to do a task, that task simply cannot be done by an automated system. And I think it's going to take a lot of soul searching with society, with the commercial world, with the military, to be able to come up with a solution to make all three of those, legal, ethical, and technology, align to make critical decisions, such as life or death situations with a robotic system.
Yeah, I think of the autonomous vehicle, what in the at the beginning of an accident, what do you do? Who do you save? What does that vehicle do? Those decisions. That's we're not going to solve that today, but it's absolutely things that need to be considered. Christy, I think you were going to say something.
Oh, it was me.
Oh,
and
sorry,
I'm
Leah.
just going to add to what Donna was saying. So in working with law enforcement, and when you say police drones, just, we never said it like that ever, no matter what, because that just sounds terrifying. I mean, that's terrifying to me, and I built them. We had almost as many attorneys as we had engineers at one point. We opened up the project to the local ACLU so that we just expressly, so that we wouldn't go into production with a constitutional crisis on our hands, because people have rights. We had to engage legal expertise for the police wanted us to engage case law support. They wanted to know how this was going to work out in court. They wanted to know how the drone would be admitted or perceived in the legal sense, how it would be understood in a legal sense in a criminal proceeding. We had to find litigation support, the litigation defense. What happens when somebody throws their shoes at the drone? In these contexts, what happens when you have these situations and you put them together? toward what Donna was saying. Like I said, we had almost as many attorneys as we had engineers.
Thank you, Leah. We're coming up to the very end of our time, and I think we've covered some of the threads of the questions that were in the chat. If we'll direct those questions to the panel directly. We'll directly direct, and we'll make sure that the answers are provided to those that participated as well today. I want to thank our panel, and I also want to thank CES for giving us the opportunity to be one of 7 partners as part of their partner program today. I think that if you have the opportunity to go and take a look at some of the sessions that were available over the last couple of days, you'll note that there are some threads within the conversation that we took place today. For those of you that are participating today, thank you very much for registering. Thank you very much for actively engaging with us. Some of the questions we've threaded into the conversation today. But if you would help me and thank our panelists for participating today and providing this information, which is really quite tremendous. So there's my polite golf clap. I'm sure everyone's doing the same. Janine, Donna, Sylvain, Leah, and Christy, thank you for your insight and your vision, and given us quite a bit to talk about. And I've written some notes that I think maybe a white paper could come from this. Here's what we've discussed. Here's what we think the innovation should look like. And here's some avenues that need to be pursued. So more to come for sure. Kimberly, I'll give you the final word. I don't see you on my screen at the moment, but Kimberly Van Vliet, of course, is founder CEO of ConvergX and the brain behind the origination of ConvergX. I'll leave the final words to you, Kim.
Thank you very much, Brad. Thank you all. That was a very dynamic and interesting discussion. So very happy you could all join us. And I look forward to you joining us again at another ConvergX event that will be coming up.